Okay, so today I want to talk about a visible half-wave rectifier. I'll explain what I mean by that. A typical rectifier circuit has a regular power diode in it, and that's fine, it works, but I wanted to make a rectifier that you can see and substitute an LED, that is a light emitting diode, for a regular power diode so you could see the operation of it. So I first want to give thanks to the folks over at Dev Explained for um, some of the circuit diagrams I got, particularly the breadboard diagrams uh, that I'll show you in a minute. Uh, and so there's two kinds of half-wave rectifier. Here's one that just takes the top half of the wave, um, and then if you add a capacitor to it, uh, then then it fills in some of the gap between the half waves. So the way I did this is I got an MCP 4231 digital potentiometer, and thanks to Bill over at dronebotworkshop.com, this is a video he did in November of 2024 about how to use these things, and these are pretty cool. The way it works is each potentiometer has a SPI address. So to write data to the potentiometer wiper, you use the SPI protocol where you first select the chip that you want, set it to low, and then you transmit the register address to the chip, and then send the wiper position, and then set the chip select high to deselect it. And then here's the loop that I used that generates a sine wave. And what it does is there's a routine that runs called write pot. So you just call that write pot value, and then it writes the chip select, then the address, then writes the wiper value, and then deselects it, just the same as this process here. The other thing I did is I built a couple of DSO 138 oscilloscopes, and these are pretty cool. You can buy these on Amazon for 25 bucks. They come in a kit. They're kind of fun to assemble. I did two of them, and then I mounted them on a bracket that I 3D printed to hold everything. And then the way it's wired up is here's the wiring diagram using the DigiPot. Again, thanks to Bill over at DroneBot Workshop. That outputs a sine wave. That goes into the half-wave rectifier. And what I did was I substituted an LED for a regular power diode. And then hook up my two oscilloscopes to it, one on the input end that has the sine wave, and the other on the output end that has the rectified wave. So here's what it looks like breadboarded up. The oscilloscope over here, you can see it's got the input signal with a full sine wave, and then here's the output signal with a half wave rectification. I use a Arduino R3, a little bit hard to see here behind all the wiring, but here's the MCP 4231 DigiPot, and then here's the half-wave rectifier circuit that's got the LED. You can see the load resistor here and the capacitor. So you run it, and it works. So if you look at the oscilloscope traces, here's the input wave up on top here. It's this oscilloscope over on the left. It looks like a nice sine wave. It's got a peak-to-peak voltage of just under 5 volts. And then if you look at the output side of it, here's a rectified wave. It's not mathematically perfect. There's this little ramp here, and I'm actually not sure why that is. If somebody out there knows, maybe put that in the comments. And you can see a peak-to-peak voltage of just under 3 volts. And then if you add a 10 microfarad capacitor to it, and you can see I circled it in red here, then the input wave is the same, and you can see there's a more of a slope after the peak voltage, which is the capacitor filling in part of that gap. And if you look at the two waves side by side, here on the left is the rectified wave without the capacitor, and then here it is on the right with the capacitor. Okay, so I made a couple of videos that I'll run real quick here. And the cool thing about this is that the LED flashes, so you can see it operating. And I've got the frequency of the sine wave set up at about 3.5 hertz so that you can see it. So let me just run this video. So you can see the LED blinking, and there's the rectified wave. 3 volts peak to peak, 3.5 hertz. There's the LED still blinking like it's supposed to. Then you come over here to the input wave, and there's a nice pretty sine wave, a little over 5 volts peak to peak. All right, just like it should be. Okay, so there it is without the capacitor, and then here it is with the capacitor. So again, the LED is blinking. There's the rectified wave, and you can see the capacitor filling in the gap there. Here's the LED and the capacitor here, and here's that nice sine wave as an input. All right, there you go. Half wave capacitor. How cool is that? A visible rectifier. Now the next step is to make a full wave rectifier, and the challenge with that is I've got to run power through 2 diodes, and each diode has a bias voltage of between 2 and 3 volts, plus there's the voltage drop across the resistor here. So the Arduino outputs, as you saw from the oscilloscope, about 5 volts, and that's not enough to overcome these bias voltages and the drop across the resistor. So what I'm going to do instead is I'm going to get a DS3502 from Adafruit. And what I can do with that is I can feed it a 9 volt DC input from my power supply, and then I'll run the same sketch on this Arduino that generates the sine wave. Then I'll input that to the circuit and hook up my oscilloscopes. So my next video, hopefully I'll be able to make a full wave visible rectifier, and it will have 4 LEDs, 2 blinking at any one time, and I'll have, you know, the pairs that operate together. I'll make them the same color so you can see it. Okay, visible rectifier, pretty cool.